It's raining notes. Here we go. We're going to solve some formulas. Multiply each term by the denominator if there is one. We will talk about that when we see a denominator. Remember, you're going to have something like, why is this not writing? You're going to have something like 4/5 x plus 2y equals 7. That's what that one means. You would multiply each term by the denominator, so you would multiply this by 5, you would multiply this by 5, and you would multiply this by 5. Distribute each term if you need to. I should not have to tell you what that means. You know how to distribute. You are machines. Get the indicated variable term alone on one side of the equal sign by moving all the other terms to the other side. Add or subtract. Okay, what that means is if you have a plus b plus c minus d equals e, and you want just the b, you got to move everything. So this a doesn't belong here, so we're going to subtract it. Cancel it. We still have b plus c minus d over here. Here you can't put e and a together, so you have e minus a. The c doesn't belong, so we subtract it. Blah, 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 blah. We're going to do a lot more examples. And multiply or divide each term by the coefficient to get the variable alone. We know what that means. Isn't she cute holding her little umbrella? All right, solve for the indicated variable. We're going to solve for y. This one, guys, is right out of beginning of equations because there's only one variable. I have 5y, 17 minus 12 is 5. I divide by 5. I get y equals 1. Bada bing, bada boom. Okay. Oh, wait a minute. Okay. Solve for the indicated variable. The thing did something funny, but we're good. Now, this time I want to solve for y. So I'm going to move that term. Oh, it's got an x. That's okay. I'm going to subtract 12x. We've done this before, haven't we? And the 12x and the negative 12x cancel. 5y equals. I can't put these two together, so I call it reading down, writing across. Read down 17 minus 12y, write it going across this way, 17 minus 12y. Now I got to divide by 5. I'm going to divide everything, each term, by 5. So I have 5y equals 17/5 minus 12x over 5. Or, because you're solving for an indicated variable and not trying to write an equation of a line, when you divide, you can just divide by sides. And that's probably what we're going to do here. We're going to go 17 minus 12x all over 5, because that's more useful when you get to Algebra 2. Okay, so solve for the indicated variable. Ooh, look, I've got a y here and I've got a y here. What that means, remember that really long one that says get the indicated variable on one side of the equal sign by moving all the other terms to the other side of the equal sign, blah, blah, blah. I'm going to move the 8y over to this side because that gets my y's together. I'm going to do that by subtracting 8y. Now I have negative 10 equals, and if I was doing 12y minus 8y, writing down, writing across, I could do that, but I should notice they both have y. If they have the same variable, I'm allowed to combine them. Then I'm going to divide everything by 4. So this is negative 5 over 2 equals y. Has anyone noticed what I'm doing on my slides yet? Have you noticed? Have you noticed? Oh, well, you should. I'm going to tell you in a little bit what that means. All right. I have a y here and a y here. I'm going to bring this y over there by subtracting 8y. So I have negative x equals, again, it's 12y minus 8y. Probably not going to write that step because if you notice they both have the y, you're going to just combine them. Now here's what's important. What is between that negative and that x? Oh, you can't see that. 1. So now I'm going to divide everything by negative 1, and we end up with x equals negative 4y. I'm using a color pen that matches the picture, which is a lot of yellow. Apparently rain has a lot of yellow in it. Okay, C equals 1/2 EH. I'm going back to the one that said if there's a denominator, multiply each term by the denominator. So I have a term of C. I have a denominator of of 2. My denominator here is 2, so I need to multiply C by 2. Then I have an equal sign. I have a 1/2 EH. Now here, this is something we really need to talk about, guys. That is one term. Do you remember when we identified polynomials as binomial, monomial, trinomial, and we said that they were separated by the plus or minus? So like you could have A plus B equals C minus D. No, there are no equal signs, sorry. Plus. So you had 1, 2, 3, 4 terms because they were separated by plus and minuses. You could also have ABC minus D, and that's still just 2 terms. So this side over here, this is all just one term because there's no plus or minus. So when I say multiply each term by the denominator, I'm going to multiply just that whole thing by 2. So over on this left side, I have 2C. On the right side, the denominator 2 and the numerator 2 cancel, and I have EH. Okay? Get rid of those fractions. We don't like them. Then I'm solving for H. So if I look over here at this term, that's where my H is. It's being multiplied by E. Opposite of multiplication is division. So this time, instead of adding and subtracting to move it, I have to divide. It's my coefficient. So what do I have left over here? I have 2C all over E equals, the E's cancel, H. Now I've solved for H alone. Why do we have to do this? While you're writing this, let me answer that question for you. Why do we have to do this? It's for our dear friends in the science department, because they do so much trial and error with different formulas. Like, what happens if I adjust the C, which is carbon, and the E, which is aluminium? And what will happen to my H, which is hypersidobia? So I have to find the effect of those on that, and they do a lot of weird little multiplying and trials. So we do this, we dedicate this to our dear friends in the science department. Okay, we are solving for y. Well, the first thing I see is a denominator. Now this one, I'm going to be honest. Look at this left side. Is it all one thing? 3x minus 2y all over 2. Yes, that's one term. So what am I going to do with it? I'm going to multiply. I'm going to actually put it in parentheses to say that's one term. I'm going to multiply it by the denominator, which is 2. Equals 5. That's a term. And I'm going to multiply it by the denominator, which is 2. So what do I have left? 2 and 2 cancel. I have 3x minus 2y, and 5 times 2 is 10. Now, who am I trying to get alone? Y. So here's the y. Let me make it a different color. There's the y that I want. So I need to move the 3x. I'm going to move the 3x by subtracting it because it's being added or subtracted to the 2y. Read down, right across. So I have negative 2y equals 10 minus 3x. I need to get rid of the negative 2, so I divide both sides by negative 2. I'm going over here, I'm out of room. So my answer is y equals 10 minus 3x over negative 2. And since I'm solving for the indicated variable, that's an okay thing to do in Algebra 1. In Algebra 2, for those of you that want to get smarty McSmartin pants, we don't like a negative on the bottom. So what you do is you just change everything. To get rid of a negative, you multiply by negative 1. So you change everything to its opposite. So that becomes negative 10, that becomes positive 3x, and that becomes positive 2. That's a little bit much for just this video. What color is the pen going to be on the next one? Yellow again. Well, this is good because yellow is my favorite color. We're solving for a. The a is in this little term right here. So that means I need to move this r. It doesn't belong there. So I have v equals r plus the a is who I'm trying to get alone, t. So I could divide by t because the a is being multiplied by t, but I got to take care of plus and minuses first. So to move that r, I'm going to subtract it because it's a positive 1r right now. Read down, right across. So what do I have? I have v minus r equals a t. Okay, let's get rid of that right across. It's in my way. Now look at where the a is. On that side, there are no plus or minuses left. So I'm going to divide everything by t. Because what does that leave me all alone? That leaves me the a all alone. We have no idea what this means. This, honestly, we just made up a in a equation. We just use a lot of variables with a lot of different things. Got to just know the process. Okay? All right, we're solving for A. Now this time I have to look. Oh, I don't know if this is going to work. There's an A there. There's an A there. If I have A's on each side of the equal sign, I've got to move one to one side, one to the other. I'm going to start by moving that A over there. Let's see if the green in his shirt shows up better than the black umbrella. Yep. So I have 9A minus 2B equals C plus 4A. To move this 4A over there, I have to subtract 4A. Now, because I have a like term this time, I have another guy with an A, I need to make sure to line it up. So 9 minus 4 is 5A minus 2B equals C. You guys get yourselves all confuzzled because, oh my gosh, there's A's, there's B's, there's C's, there's numbers. What do I do? What do I do? What do I do? Help me, help me. It's raining numbers. So what you have to remember is the same thing you've always done. To move one thing from one side of the equal to the other, you add or subtract, and if it's got a like term, you put them together. Okay? Now, I am solving for A. So here's the term with the A. So I've got a minus 2B in my way. So I have to add 2B to move it to the other side. All righty? So now I have 5A equals, read down, right across. What does it even say? It says C plus 2B. I can't put them together. They're not like terms. The A is being multiplied by 5, so I'm going to divide everything by 5. So my final answer is C plus 2B all over 5. Problem with these answers, we don't like them. I can't measure it. I don't know what it means. Yeah, well, sorry guys. Fortunately, that's life. I don't have pink. I'm going to use purple. Okay, sorry. I don't think purple's going to show up, but we're going to find out. Do you notice? No, purple doesn't show up. I'm not using purple, guys. I'm going to use white. I use the background. Do you notice there is a fraction? So you're going to write this entire term, and you're going to multiply it by the denominator equals this entire term multiplied by the denominator. So what do you have left? 3ax minus n equals negative 20. Okay, you know what else you could do, guys? Let me just tell you, show you. If you put that over 1 and you cross multiply, you get 3axn when you multiply this way, and when you multiply this way, you get negative 20. It's a proportion. All right, we are solving for x, which is right here. So I need to move that minus n. I do that by adding n to both sides. Cancel it. I have 3ax. Remember, read down, right across. What does it say? It says negative 20 plus n. I can't put it together, so I'm going to just leave it, negative 20 plus n. Over here, no addition and subtraction, so I'm going to divide. What do I want? I don't remember anymore. I want the x, so I'm going to divide by 3a. Divide by 3a. The 3's cancel, the a's cancel. So my final answer is x equals negative 20 plus n all over 3a. Again, I don't know what it means. I don't care what it means. I solve for x. It's alone. All right, we're going to solve for m. Oh, I have choices, 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 choices. We're going to use orange because we haven't used orange yet. Orange, this one right here, dedicated to this guy, okay? I have 3/5 m. That's a term. I'm going to multiply by the denominator, which is 5, equals b. That's a term. I'm going to multiply by the denominator, which is 5. Remember, the reason I do that is it cancels the denominator on the term that has it. So now I have 3m equals b times 5 is going to be written 5b. If you write b5, that's okay. It's just when it's multiplication, we put the numbers in front. I'm solving for m. It's being multiplied by 3, so I'm going to divide both sides by 3. So m is going to be 5b over 3. You know what this formula stands for? My birthday is May 3rd. I'm sure that's what it stands for. That's a secret word. All right, here we go. Oh, look at this cute little ducky. All right, we are solving for L. L is in this term right here. So I have P equals 2L. I'm going to make a capital L just because otherwise it looks like 21, okay? On the side where there is an L, there is a plus sign. If there's a plus sign, I have to use subtraction to move the term I don't want. So 2W minus 2W cancels. Read down, right across. What does it say? P minus 2W equals 2L. That's the L that I want. It's being multiplied by 2, so I'm going to just divide both sides by 2. So P minus 2W all over 2 equals L. Do not try to cancel the 2's. That's what the whole first 2 lessons were about. Remember, I can't cancel unless things are being multiplied. I can't cancel with a minus sign unless it's an entire parenthesis. So leave it that way. That is an application of lessons 8.1 and 8.2. Do not cancel unless they are multiplied. All right. Last slide, solve for the indicated variable. And could it be messier? No. Well, yeah, it could be. But there is a denominator. I'm going for I don't care. I'm getting rid of the denominator. L is a term. I am going to multiply it by the denominator, which is 2. Then I have equals. Now, remember, this entire 1/2 x plus y is one term because everything's multiplied. 1/2 times x plus y. And I'm going to multiply this by 2. These 2's cancel. Leaves me with 2L equals x plus y. I want to get the y alone, so I got to move that x. It's being added. I'm going to subtract it. Over here, read down, right across. 2L minus x equals y. Y is alone. Y is happy. Y is you still listening to me, because we is done. See ya.